Okay, let's take a look at this test review. And I know this is small, and I apologize. I've been sitting here fiddling with this for the last half an hour trying to get it to larger size. I can make this larger, but whenever I bring up the quiz, and it's this size, so I'll read it, and hopefully that's be good enough. Tried to bring it up in IE. Not that I can resize in IE, but for some reason, IE doesn't work on this computer in terms of my math lab. Google Chrome does. Okay, I'll quit whining. Okay, a pediatrician wants to determine the relation that may exist between a child's height and head circumference. She randomly selects 8 children, measures their height and head circumference, and obtains the data shown in the table. And says click here to see a table of the critical values for correlation coefficient. Okay. If the pediatrician wants to use the height to predict head circumference, determine which variable is the explanatory variable and which is the response. Use height to predict the head circumference. So the height is going to drive the head circumference. So the explanatory variable is the height, and the response variable is the head circumference. Now it says that we want to draw a scatter diagram. So let's put these in our calculator. So I'm going to come over here. I'll press my stat, do enter on edit. I have numbers here. I'm just going to press delete to clean them out. Make sure that L1 or L2 isn't highlighted when you're pressing delete. Otherwise you'll delete the list, which isn't good. You can add it back in, but... Okay, so I got 27, 25.25, 26.5, 25.5, 27.25, 26.5, 26.25, 27.25. Okay, then I'll write her over to L2, and I'll put in my head circumference there. So I got 17.4, 17.2, 17.3, 16.9, 17.4, 17.3, 17.2, 17.4. Now I'm really bad about data entry, so I'm going to double check myself in all this. Okay, 27.25, 17.4. 26.25, 17.2. 26.5, 17.3. 27.25, 17.4. 25.5, 16.9. 26.5, 17.3. 25.25, 17.2. And 27 and 17.4. Okay, that all looks correct. Now, I think I can also click here. Oh, I thought I could, never mind. I thought I could bring it up in larger so you could see it a little bit better. I know that's small. Okay, draw a scatter diagram. I'm going to exit out, so I'll do a second mode. I'm going to press my Y equals. I probably have something on here from algebra or calculus or something, so I'm going to clear that out. I press clear. You don't want anything on Y1. Then we're going to do second, Y equals, and we're going to go into plot 1. So I do enter on that. Now you want to select the on. So if your flashing cursor isn't on the on, do your left arrow or whatever to put the flashing cursor on it, and press enter one time. Now a down arrow. This first one is our scatter plot. It should already be selected, but if it isn't, make sure your flashing cursor is on the first one and you press enter. And by default, it should point to L1 and L2. If it doesn't, you come down here and it says something else. You can do second 1. So press the second button and then 1 to put L1 there. And for L2, you can do second 2. But mine's fine. Now I'm going to exit out. So do second mode, press zoom, and I want to choose the 9th one. Now I'm going to down arrow to it and show it to you, but you can just press the number 9. Oops, one too many. So we want zoom stat. So I press enter, and that's our scatter plot. That's kind of all over the place, isn't it? Now these I'm gonna have to make bigger. My eyes aren't that good. That doesn't look like it. That doesn't look like it. Well, actually, it's a little bit tricky here. I think this bottom one, the bottom two are not points. I think those are axis. So let me focus on this up here. Might be this one. Let me see. Got the 2 up there. Those 2 down like that. That's close. 1 there. 1 there. So 1 there. Let me look at the other one that looks that way. Look at this one. So get the 2 down like that. 1 like that. Maybe a little bit trickier because my my y-axis, this is from 16.9 to 17.6. Now it's probably not what my calculator is. If I did my cursor, doing a down arrow, 16.9 they have right there. My 16.9 is right there. Okay, so that is a 16.9 right there. Okay, so that looks like the one actually. I'm trying to see what the difference between this one. Maybe technology is not the best way to do this anyway. Okay. Well, now this says circumference is on the bottom. That's not right. So that wouldn't be right. Height has to, okay, height has to, these are like our x values and these are our y values. So height has to be on the bottom. So, okay, now I know the difference between these. This graph and the other graph looked almost exactly the same. I wasn't looking at it close enough. See how it says height on the bottom? So that's what we want. Okay, compute the linear correlation coefficient. I'm going to exit out, do second mode, choose stat, I'm going to right arrow to calc, and I'm going to choose number 4. And then I'll press enter, and it assumes that you put your x values in L1, your y values in L2. So the r's are correlation coefficient, and they want it to 3 decimal places. So 0.823. Okay. Does a linear relation exist between the height and okay. Yes, there appears to be a negative linear correlation because r is negative. R is not negative, so that's not right. Yes, there appears to be a positive linear association because r is positive and is greater than a critical value. Let's see what our critical value is. Let's see how many data points we have. We have 3, 4, 5, 6, 7, 8. 3, 4, 8. So if I click here, I go look up 8 for the critical value. It says 0.707. Now, let me bring up my PowerPoint for this so you can see. And eventually it'll come up. There it goes. Okay, so I'm going to go into elementary statistics, and I hope I don't have a bunch of troubles here because my flash drive died, and I don't see section 4.1. I don't think it's in 4.2. Well, let me download it again. Okay, I'm going to Math Heals. I'm going to Math Class Information, Elementary Statistics. And I go to 4.1 and we're at the PowerPoint. And to take a little bit here. Basically, we're comparing the absolute value of R to the critical value. Image cannot currently. Boy, nothing's going to work tonight, it seems like. Here it is. At least this slide came up. Okay, so this is checking if the absolute value of R is greater than our critical value. Okay, so we said we had 8 items. Critical value is 0.707. And the absolute value of R is greater than that. So absolute value of R is greater than it, says linear relation exists. Okay, so it has to be one of these yeses. There appears to be a positive linear because R is positive and greater than the critical value. R being positive has nothing to do with it actually, but because our formula says you compare the absolute value of R. Yes, there appears to be a positive linear association. This is just checking to see if it's a linear relation. Okay, because R is positive is less than the critical value, so it'd be B. And we'll go to the next question. Okay, engineer wants to determine how the weight of a car affects gas mileage. Following data represents the weights of various cars and their gas mileage. The engineer wants to determine how the weight of a car affects gas mileage. So weight is driving the gas mileage. So weight is our explanatory. So explanatory variable is weight, and response is the miles per gallon. Okay. Now you can think of your weight as your x values and your miles as your y values. So drawing a scatter diagram, if these are our x values, then we want weight on the bottom. So it's going to be either boy, my eyes are bad. D, I guess that says. Looks like it's been partially cut off, but let me take a look at this. Might be easier just to eyeball it than plug it in the calculator. Okay, weight is 39.85. Let's see, normal. Okay, that's 4,000. This is 2,500, so that'd be 3,000, 3,500. Okay, so I know where I'm at. And 2580 and 27. That's 30. This is 15, so 20, 25, 30. Okay. So 2580, 27. That looks good there. And then this one would be about 21. Yeah, that looks about right. Okay. Let me actually plug this in calculator. I have to do it anyway. Though I had such poor luck with that first problem, I hate to do it again. But stat and edit. And I'm going to up arrow and highlight L2 and press clear. Don't press delete. And now it clears out your list real fast. And I'm going to up arrow here, highlight L1, press clear and enter. And now it'll clear out the list real fast. Now if you press delete by accident, if you come up here and you highlight L1, you press delete. Say you come in, you notice, whoa, L1's gone. Well, you do an up arrow, highlight L2, and then you second delete to choose insert. Now don't just press delete again, you'll be deleting another list. And then you do second 1 to put the name back in there of L1, and then you press enter. Okay, I'm a down arrow, and I'm going to put in 3985. So 3985, 2580, 2580, 3100, 3310, and 3565. Okay, I'm going to press my right arrow key. 18, 27, and 21. So 18, 27, 21, 19, 20. I'm going to exit out, so do second mode. Now, press clear to clear that out. Our graph should still be turned on. So all I have to do is do a zoom and press 9 for zoom stat. And there's our scatter plot. So weight is on the bottom because we said that was our x values. So it's either going to be this one or this one. And it looks like this one. If I expand it a little bit, see how those points are, and see how these points are here. Now that I'm seeing that, what's across the bottom, it really helps with that. Now I want the compute the linear correlation coefficient. So I'm going to exit out, do second mode. I'll press stat, and then I'm going to choose calc, and I'm going to choose the fourth one. So I'll press 4, and then I'll press enter. R is negative 0.3 decimal places, 899. 899. Okay. Does a linear relation exist? There appears to be a negative, positive. Well, it's a negative correlation, if any, because of the way the points are going down. See how they're going down? Let me expand it. See how they're going down from left to right? So that's a negative association. But let me That's interesting. There's no link here. If I can go back to the previous problem. Yeah, you sure want to leave this question. Yeah. Okay. We had 5 data points. So I'll come back here. And I want to click the table of critical values. And for 5, we got 0.878. So 0.878. If I come over here, if I take the absolute value of this, it is greater than that. So that means there's a linear relation. And again, what I'm going off of this right here, if the absolute value of R is greater than your critical value, linear relation exists. Okay. Let's see. R is positive. That's not true. There's a little no. Okay, there appears to be a positive linear. It's not positive. There's a negative because R is negative and less than the critical. The negative critical value. It's kind of a bad way to put it, but I know what they're saying. But it still goes back to this right here, where you're comparing the absolute value of R to the critical value. Okay, next question. Scatter diagram is given. Determine least squares regression line and graph it. Okay, so let's enter this in. I'm going to go to my stat, I'm going to my edit, clear. And I never have taken this test, so me stumbling around, realize that I'm going at this cold. I figure that's what you guys are doing. 0 through 6, so 0, 1, 2, 3, 4, 5, 6. And a right arrow over, and I'll put in 7.2, 7.2, 5.4, 6.3, 6.2, 4.6, and 2.4. Assuming my data entry is good. Actually, it isn't, because I got too many values. 0 through 6, 7.2, 5.4, 6.3, 6.2, 4.6, 2.4. What in the world am I missing? Oh, this is not dealing with Mr. Magoo here. Okay, 0, 1, 2, 2, 4, 6. So 2, 2, 4, 6. I'll delete that one. There we go. Helps to actually be able to see. So I'm going to exit out to a second mode. I'll press clear on that. And I want to go into stat, right arrow to calc, and choose linear regression again. And then press enter. Okay. So first thing, they want the y-hat, linear regression line. and round to 4 decimal places is needed. So the A is what goes before our X, which is what they're asking for right here. So negative 0.7255. Okay, now B is the number that goes at the end, which is 7.1638. 7.1638. Okay, now it says choose the correct graph. Boy, they look pretty similar, don't they? Let me do a scatter plot over here. So I'll go to my zoom, and I'll choose 9 because again, the scatter plot should already be turned on. Doesn't look very good, does it? One, two, three, four, five. 1, 2, 3, 4. Looks like I'm missing a data point. Unless they're very close together. Ah, they are. See how these two are close together? Okay, that makes sense. Now, now we want to graph this. So I'm going to go to y equals, and I'm on y1, and I'm going to put in negative 0.7255x. So negative 0.7255x plus 7.1638. And now if I press graph, I'm going to see my line drawn through there. Okay, now I'm going to my eyes aren't very good, so I have to blow these up. That one looks close, doesn't it? I think that's the one, actually. But let me look at these other ones. Okay, this point here is below that line. This is on that, so that's not it. This one is lines on it, so that's not it. So it's either going to be this one or this one. Let me look at this one a little closer. Okay, now this point is above it, so it's not that one. It's this one. Okay. Now click on next question. I'm going to be mad if one of these is wrong. I'm typing a number wrong or something. Okay, so determine least squares regression line. So we got some new data. Press Stat and go into Edit. Now up arrow, highlight L1, press Clear, Enter. Don't press Delete. Come over here, up arrow, highlight L2, press Clear, Enter. Let me go back to L1 now, and I'm going to put in 4, 5, 6, 7, 9. 4, 5, 6, 7, 9. So 4 enter, 5 enter, 6 enter, 7 enter, 9 enter. Go over to L2, and we want to put in 5, 6, 10. So 5 enter, 6 enter, 10 enter, 9 enter, 14 enter. I'm going to exit out, do second mode. Now I'm going to go back to the y equals, and I'll press Clear to clear out that y1. I'll do second mode, exit out, press Clear, and I want to go get my regression line. So I'll press Stat, right arrow to Calc, and I choose number 4. And then press Enter. Okay, so there, A is what's before our X, so 4 decimal places, 1.7703. 1.7703. And then this number here is our B, which is negative 2.1757. 3 decimal places. Whoa. 6. And that's there. Did I read this other problem wrong? Let me go over and look at it. 4 decimal places. Ah, nice consistency. So I want to keep you on your toes. Okay. So I'm going to press Zoom, and I'll choose 9. That'll give me my scatter plot. So now I'm going to press Y equals. And on Y1, I'm going to put this. So I got 1.770x, 1.770x minus 2.176. And then press graph. Okay, so that one looks like it's almost straight through it. This is below, that's below, this is above. Okay, so that one isn't it. Everything looks like it's on a line on this one. That's definitely not it. Looking for one above, two below. One above, two below. That might be it. I'll come back to that B. Two above, that's not it. And that one, they're pretty well on the same. So this one right here, one above, two below. That looks like this. One above, two below. I know it's not exact, but to B. Compute the sum of the squared residuals for least squares regression line found in part A. The sum of the squared residuals for least squares regression line is, then they ask you to tell that. What's the easiest way to do this? These are kind of tedious problems. I'll use the calculator to do it, I guess. If I go back to my stat and I go over to my edit. Now remember, your L1 is your X values, your L2 is your Y values. So I come over here to L3, up arrow to L3, so I'm highlighting it, and we want to put in this formula. So I got 1.770x. Now the X is going to refer to my X values in L1. So I'm going to have 1.770 times, and then we want L1, so do second one, then minus 2.176. So again, that's our linear regression equation. I'm replacing X value with L1. And I press enter. Now this is our Y hat. So I'm going to come over to L4. I'm going to press up arrow. And the Y values are in L2, so remember that. And the Y hat's in L3. So this we want as Y minus Y hat squared. So I'll do a beginning parentheses. Y we said was in L2, so I do second 2. Minus Y hat, which was in L3, so I do second 3. Closing parentheses, squared. And then press enter. So these are squared residuals. So it's an L4, so keep that in mind. I'm going to exit out, do second mode, and then I'm going to press my, where's it at? Let me try going on math. Looking for the sum feature. Min, F part, round, doesn't appear to be there. Not under math. Let me go to second math. Second stat. There it is. Second stat. Go over to math, and there's sum. And now we're going to do L4, so do second 4, put L4 in there, and press enter. And that's our sum of the squared residuals. So to 3 decimal places, 4.419. 4.419. Okay, and I'll say next question. Oh, finally done with those hideous enter the data problems. Okay, some good probability now. This says a bag of 100 tulip bulbs purchased from nursery contains 15 red. So 15 red, 35 yellow, 50 purple, and 100 total. What is the probability that a randomly selected tulip bulb is purple? A randomly selected, so we're selecting one. Well, there's 100 total, so that's what goes down below, and there's 50 purple. So that'd be 50 over 100. Now it says type an integer or a simplified fraction. And this is a pretty simple one, but let's say you're not very good with fractions. You can't see that's 1/2. You can go to your calculator, and if you do 50 divided by 100, and then you press Math, Enter. That'll reduce the fraction for you. So again, I put in my fraction, 50 divided by 100, and I press Math, Enter. So if I come over here and type a simplified fraction, I'll click the fraction symbol. I'll put in 1, click down here, put 2, and go to next question. Okay, standard deck of cards contains 52 cards. So 52 cards. One card is selected from the deck. Compute the probability of randomly selecting a spade or a heart. So it's going to be a spade or a heart. Now the or is addition. And we've got 52 cards. Of those 52 cards, 13 of them are spades. And for the heart, we've got 52 cards. Of that, 13 of them are hearts. So if I add those together, it gives me 26 over 52, which looks like 1/2 again. Let's see what it's wanting though. Type an integer or a simplified fraction. Okay, so click in here, click that, and I put 1 divided by 2. Because 26 is 50 over 52 simplifies that. If you don't see it, plug in your calculator. Okay, probability of a spade or a heart or a diamond. By the way, there's no way it could be a spade and heart at the same time, so that's why we didn't worry about subtracting. That was 1/2. Okay, probability of a spade, heart, or diamond. So spade or heart or diamond. Well, there's 3 fractions here, separated by pluses, because or means addition. Now a spade. Well, it's 52 cards, 13 of them are spades. Heart is 52 cards, 13 of them are hearts. And diamonds, there's 52 cards, 13 of them are diamonds, which gives us 39 over 52. Does that reduce? It's been a long day. Let me go use a calculator. I'll be lazy. Okay, 39 divided by 52, Math, Enter. 3/4. Okay, so come here, click my fraction, put 3, put 4. Now 9 or a heart. So I got a 9 or a heart. Well, there's 52 cards. Of those 52 cards, 4 of them are 9s. Or is always plus 52, and there's 13 hearts. But one of these 9s was a heart, and the 13 hearts here included 9 of hearts. So we counted 9 of hearts here and 9 of hearts here, so we have to subtract it off. 4 plus 13 is 17, minus 1 is 16. And again, I don't want to think that hard, so I'm going to use a calculator. So 16 divided by 52, Math, Enter. 4/13. So I'll come here, click there, do the fraction, 4/13. Next question. Let me grab a drink here. Okay. Let's look at this problem. It says, suppose Ari loses 47% of all checker games. So probability loses is 0.47. So then the opposite of that, probability wins, will be 0.53. Now when I say opposite, win is not necessarily the opposite of lose. It could be draw or so forth. But we like to keep this real simple with one word explanation. Even if it's not technically correct, do not try to make this more complex than that. Okay. What is probability Ari loses 2 checker games in a row? So loses and loses. Well, and is multiplication. So we're taking 0.47 times 0.7, or 47, which gives us 0.47 squared. Now B says probability area loses 5 checker in a row. Well, if this is a second power, then 5 losses, so loss and loss and loss and loss and loss. Might hit that record player, it's stuck. Okay, we got 5 L's. There's an implied and there. Loses 5 checker games in a row. So we lost the first one, and the second one, and third one, and fourth one, and fifth one. Sometimes the and is not so obvious. Now again, we could write it out as 0.47 times 0.47 times 0.47 times 0.47 times 0.47, or just simply write 0.47 to the 5th power. Let's plug those in. Probably wants decimals, 4 decimal places. And no memory. What did I say? 0.47 squared and 0.47 caret 5 for the 5th power. So the first one is 0.2209. 0.2209. I will guarantee you if I miss any of these, I'll go back and see what in the world I did wrong. So 0.0229. There we go. Next question. And oops. Let's start a new page. A test to determine whether a certain antibody is present is 99% effective. So probability effective, what's a simple word for that? Works. Is 0.9992. When they give you a percent, they're giving you the probability. You just need to change it to decimal form. So you move your decimal place 2 places left. This means that the test will actually come back negative if the antibody is not present. Test. I hate these science ones. They just throw me. That's not present in the test subject. The probability of a test coming back positive when it is not present is 0.08. That makes sense. So works, and I'll say fails. So again, I want to keep these one-word explanations if I can. Okay, suppose a test is given to 7 randomly people who do not have the antibody. What is probably the test comes back negative for all 7 people? Negative. Test to determine is present. This means that test will come back negative if the antibody is not present. Okay, we'll come back negative, and they're asking, comes back negative. So antibody is not present. And determine whether certain is present is 99. Probability of a test come back positive. Okay, I'm probably thinking about this too hard. The fact that they say negative, if antibody is not present and if it's present. Well, this is kind of tricky reading. Let me read a little closer. Test to determine whether a certain antibody is present is 99.2% effective. This means that tests will actually come back negative if the antibody is not present. Okay. Suppose tests given to who do not have the antibody. And all tests are negative. Okay. So, part A. I guess negative and positive might have been better ones to go with. So, let me come here. Poor choice of words, I think. Negative. And this one will be positive. Let me guess, see if that's right. Okay, false positive is 0.08. Okay, so all 7 tests are negative. So first one's negative, and second one, and third one, and fourth one, and fifth one, and sixth one, and seventh one. So that'd be 0.992 to the 7th power. B, at least one positive. Well, we rewrite this, at least one positive. This becomes 1 minus probability of none positive. At this point in time, at least one here, whatever wording is here, it matches right here. So positive, positive. And we rewrite as 1 minus probability of none. It's always the same. This then becomes 1 minus probability of all. And we switch this wording here, this positive, to the opposite, which is negative. So again, we switch the wording when we change the none to all. Okay. Now negative, we said was 0.992. And are we still talking about 7? Come back for at least one of the 7 people. So it'd be that. At least one's a little bit tricky, but again, you do probably at least one, and then whatever word, try to keep it one word, not like a bunch of words. Then you rewrite as 1 minus probability of none, and the wording matches. Then you rewrite as 1 minus probability of all, and the wording switches the opposite. It goes to negative. So let's see what those give us. 0.992 to the 7th power. So our first one will be 0.9453. 0.94. 0.9493. 9453. 9453. And then do 1 minus that value. So you can do 1 minus second negative to bring up the previous answer, or you can just type it in. And that's 0.0547. 0.0547. 0.0547. Okay. Go to the next question. Number 9. Suppose the 2 cards are randomly selected from standard 52 card deck. What is the probability the first card is spade, second card is spade if sampling is done without replacement? We don't put the card back in. So the first one's a spade, and the second one is a spade. Okay, initially there's 52 cards. Of those 52 cards, 13 of them are spades. Now I always mentally envision this. I pulled out a let's say a 5 of spades. Well, that means there's 51 cards left in the deck, and of those 51, there's 12 spades because I already pulled that one card out. Now B says if sampling is done with replacement, first card, the probability of the first card is spade and second one is a spade. Same setup. We got spade and spade. Well, our first one is 13 out of 52. We've got 52 cards, 13 are spades. Let's say I pull out the king of spades, and I look at it and say, oh, that's nice, and I put it back in the deck. That means that 52 cards are back in the deck, or still in the deck, and of those 52, 13 of them are spades. How do they want the answer? Round to 3 decimal places. 3. Okay. So let's plug this in the calculator. So I'm going to do 13 divided by 52 times 12 divided by 51. Enter. 0.059. 0.059. Okay, the next one. We're going to have 13. Actually, remember this. 13 out of 52 times 13 out of 52. I don't usually remember the problems when I'm working them, the numbers. Press enter. And 3 decimal places, 0.063. So 0.063. Okay, so next question. Number of different the top 3 finishes possible for this race of 55 cars is. It says suppose 55 cars started a car race. How many ways can the top 3 cars finish a race? Well, in this one, order matters. You're finishing a race, whether you come in first, second, or third matters. So we're going to have 55 cars, and we're going to have NPR. Permutations where order matters, combinations where order doesn't matter. And we're picking 3. So that's how we're going to plug it in. So 55, and where's that at? Second math or math? Math. And then go to PRB, NPR, so choose 2, and then 3. Enter. 157,410. So 157,410. Now I'm going to click Submit Test and hope and pray I got 100%. Probably didn't. I'm sure I missed at least one. Oh, that's unreal. Okay, I got 100 out of 100. I expected. I was fumbling around on that first one because I didn't take this. I wanted to take it cold. A little bit more entertaining for me, and you can kind of see my thought process as I'm going through the problem. Not everything's so clear-cut in statistics, and sometimes you just have to really think about it and examine it and think what they're asking. I don't know what I need to do here. I don't take my math lab tests. Go to results, I guess. And there's 100 out of 100. I started this one for 2 minutes because I was trying to figure out how to zoom, and that didn't go well. But you can see I didn't do very well on the test. Got a 0. Of course, I only spent 2 minutes on the entire test. But anyway, that's a Chapter 4 or 5 test review, and I apologize for the stumbling around at first. I should read problems closer. I should look at those details. But keep that in mind when you're working a problem, to take a look at what's on the x-axis and what's on the y-axis. And the explanatory variable is always on the x-axis.